So our next one is solved by graphing. So move to this flap. And you'll notice on the other side of your whiteboards is graph paper. Have your students graphed a line by this point? Yes. 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 So that was a really quick 4 graphs. Then you can stick it back into the folder. Students know to graph.
Y-intercept and slope.
They know how to. They know how to graph with a table. They know how to graph with slope, intercept. Tell me 2 different ways your students know how to graph.
By table and slope intercept.
Yes. Oh, it would be good two partners. Each one gets the equation on the top of each desk. So like if Jennifer has one equation, mine had the other.
Right.
So you're building one system.
So she builds one equation, I build the other one.
Okay.
And then she's got y by itself, so I take my y out and put in her.
So the ruler's in between the desks.
Yeah. Well, the
ruler's in between the equations.
Each one of us have a ruler because we each have an equation.
Okay, right.
Okay.
This is cool. This
is
way cool.
It is way cool. And this was Christian goes, we're going to do it with tiles. And I'm like, huh?
That's what I went on. I got to do this.
Okay. So here's what we have. We have y equals 2x plus 5 on this side. Would you come up here, Alyssa, for this one? Let me get a clean piece of paper. So, are you ready? If y is equal to 2x plus 5, can I replace this y with 2x plus 5?
Yes. Yeah.
So take it out and you put in your 2x plus 5. Woohoo! Okay, so now over here I have what?
Oh, you know what Jennifer just said? How you got your hand down on your other y? Put it back up on the other side of your equal side because you just replaced the y with partners. So y literally handed. You trade pieces like changing.
Right here?
Yeah, okay. Like that. Because you like 4 quarters and $1. I'll give you 4 quarters for my $1. Now you got the $1 and I got the 4 quarters.
And we were so now I have this, correct?
You're doing that with your partner.
Yes.
Okay. Are you? Oh, is she standing in front of your screen? Okay. So now, from cups and tiles, from our last time, how do I solve with cups and tiles? I have 5 cups plus 5 tiles equals 10 tiles. What do we do to get rid of our tiles? You put 5 negatives. If I add 5 negatives to this side, I have to add 5 negatives to this side. Why do I do that? No, that's not why we do it.
Keep the equation balanced.
The balance of the equation. Equivalency. Remember that the term equivalency needs to come up for this.
One of your negatives, you have it positive on that when you added the 5.
Okay.
Yeah, there you go.
Okay, so we added 5 negatives to both sides. That makes these become a what? A 0 or a neutral field. So they can float anywhere they want in the air, right? There are a bunch of little zeros running around. Okay, and now we have some more zeros over here. And so we have 5x is equal to 5 cups and 5 tiles. So how do I figure out how much is in 1 cup? Divide them both by 5 by the number of cups. So I take my 5 tiles, or my 5 cups, and I put 1 cup in each, or 1 tile in each cup until I run out. So for each cup is 1 tile. So x is equal to 1. So I felt like this was way cool when she brought that up and said, yeah, we should be able to do it. Now this was where we struggled. Now what?
So go back and replace your y with what y is equal to. It's equal to 2x's plus 5.
So we go
rebuild
back
the
and
equation.
rebuild this one. Okay, so 2x plus 5.
We just buy it.
And on the right side,
Yeah,
I
you
would
want that
represent
right
that
back.
x equals 1, maybe on the bottom part. And then you could do the replacing thing again, if that makes sense.
Say that again.
So on the bottom part, put x equal to 1. So do another visual
Right here?
aid on your right
Oh.
side.
Goes one.
And then you
Ah,
could do your replacing it also.
x equals 1. Okay, I was
So
going to
for
rebuild
each
this
one
one.
of these,
Positive one.
I can say
Yeah,
one to there, one to there.
So now for every x in your original y equals equation, you could replace it doing the partner thing.
Okay, so if x is equal to 1, each of these x's are 1. So I'm taking these out and replacing them with 1, which makes y equal to
Key again, you're substituting again.
Yeah.
7.
Yeah. That's
Like that.
So what's your point of intersection?
1, 7.
1, 7 is your point of intersection. How do you check to make sure?
Plug it back in.
Plug it back in you have, for both equations. So 7 is equal to 2 times 1 plus 5. 7 is equal to 2 plus 5. 7 is equal to 7. Yes or no?
Yep.
Yes.
Check. Just because it's correct in one, does it mean it'll be correct in the other one automatically? No, so you must check the other one as well. 3 times 1 plus 7 equals 10. 3 plus 7 equals 10. 10 equals 10. Check. Cool. I think we'll be on the news tonight for what we just did. Okay.
That's the best part of these workshops with sitting with your department and just collaborating and brainstorming. How am I going to teach this? We all know how to do this, right? We're not insulting your intelligence, but teaching you how to solve systems. We know how to do it, or how to understand it. But can we teach it? Can we teach it to a level to our kids? We have a variety of different kids. I have, low kids. Someone may have really high kids where, I can't pull out tiles now or whatever. So it's really great that we had
Just the brainstorming ideas.
Brainstorming.
Like here, Jennifer saying, well, put your y back in where you
Right.
swapped it. I wouldn't even thought of that. So just the brainstorming together, being able to process.
Spending time together as teachers is really
valuable.
valuable.
Yes.
And doesn't happen very often.
I like how Ellen said.